Hi everybody, so this is going to be looking at Mod 2, Topic 3, Lesson 2. And this is going to be about transformations of rational functions. So let's just start by reviewing transformations in general. Okay, if you take any function, f of x, and you multiply the front of that function times an a, that is going to give you a vertical stretch of some kind. And if that a is a negative value, less than 0, it is going to create a reflection across the x-axis. B, which is inside, and it affects the x value, not the whole function, just changing the x value, is going to be a horizontal stretch. And if that value is negative, it's going to be a reflection across the y-axis. We don't see B too often, but it can happen. C, notice C is after a subtraction sign and it's affecting the x. C is a horizontal translation or a shift. It basically moves the graph left or right, but you have to be careful about that minus because it's basically the number there is opposite of what we see. And then finally we've got D. D is at the end here and it's adding. It is a vertical translation. It moves the graph up down. Okay, so let's go ahead and take a look at the types of functions, rational functions with these translations. Okay, so I'm going to open up a Desmos window. And we're going to play around with these with the very basic rational function 1 over x. So let's take f of x is equal to 1 over x. Okay, this is the hyperbola that we kind of talked about in the last video and in the last bookwork lesson, the introduction to rational functions. So I'm going to keep that one there, but I'm also going to create a g of x, and I'm going to affect f of x, and we're going to play with c. So if we do f of x, so let's start with d. D is easier. So d goes on the outside. Let's add 4. So you can see that the graph is going to move up 4. Now I want you to pay attention to what happened to the asymptotes. So our vertical asymptote of x equals 0 didn't really change. When you take something that's a vertical line and you move it up, it doesn't really do anything. The horizontal asymptote that we had was y equals 0. You can see that that did change. It moved up because now it's at y equals 4. So the horizontal asymptote did change when we moved things up. What if we move things down? Then you can see the blue graph moved down. So here's where it was. It moved it down. So we subtracted 4. So our vertical asymptote, the green line there, did not change. The horizontal asymptote, we need to make that a negative 4 now. That's where our horizontal asymptote is. All right, what if we, what is that function, f of x minus 4? Well, it's essentially if I just took 1 over x and subtracted 4 at the end of it. Okay. Let's see. Well, okay, what happened here is now I'm subtracting 4 from the thing that I have written. Whatever I have written is what I'm changing. So I actually accidentally changed both of them. What I'm going to do is I'm going to have to come up with a new function. I'll call it h of x. So it's going to be 1 over x minus 4. And there we go. So you could see the blue one and the black one are right on top of each other. They're equivalent to each other. So if you take f of x and subtract 4, or if you take 1 over x minus 4, it's the same thing. Okay, what if we mess with the c now? Okay, so I'm going to do g of x, and how we write it is you have to inside the parentheses of the f of x. So it's f of x minus, let's say, 2. All right, let me change the color since they're both red. Okay, so orange one is the x minus 2. So you can see that it moved to the right 2 places because your c value that we plugged in was 2. I know it says x minus 2, but the c value itself was just positive 2. So the horizontal asymptote didn't change, but the vertical asymptote does indeed change. It was x equals 0. Now it's going to be x equals 2. So when we affect the x, we put an x minus c, an f of x minus c, what's going to happen is it's going to move things horizontally and it's going to affect that vertical asymptote. So specifically, the equation that we're doing is 1 over x minus 2. We're replacing the x with x minus 2. So the reason that you're getting a new vertical asymptote is there's a new number that will make that denominator equal to 0. So before it was 0, you plug in 0 right here, you're going to get 1 over 0, which is undefined, which gives you the vertical asymptote. With this one, you're going to plug in 2. 2 minus 2 is 0, and 1 divided by that 0 would be undefined. So that's why you get a different vertical asymptote. Okay, what if it was plus 2? Well, it moved to the left, and that's because what I'm essentially plugging in is I'm plugging in minus a negative 2. We know subtracting a negative is a positive, and so because I'm plugging in a negative 2, it's going to be a negative 2 asymptote. Okay, so let's look at a few of the questions in the book. And I'm going to tell you which sections you can skip, because some of them, we're just going to focus on the key stuff here. Okay, so we're focusing on Module 2, Topic 3, Lesson 2, Approaching Infinity, Transformations of Rational Functions. And I just want to point out one thing that I noticed. There are 3 videos on here, but the top 2 are the same. And there is a part 2, and I'm trying to find it for you, but you should be able to do okay with just part 1 and part 3, but you should watch those. I'm considering my video kind of in addition to these videos, but we'll go over different examples than them. Okay, so let's go ahead and attack some of the questions in the book. Okay, so we kind of already went over this thing right here, the functions, the transformation of functions. This is a specific one for 1 over x, but it's pretty much just the same idea. A, B, C, and D all do the same things that I already told you. Okay, for right now, there are some graphs and some equations that you have to match, and it's great practice, but I don't know that it's necessary, and I don't know that it would be so easy without to do this first. So I'm going to say put that off. If you have time for it, do it. If not, it's okay. So we're going to start on page 391 with activity 1. So we've kind of already looked at what happens with the C and the D. I didn't really focus on A and B, but we're just going to focus on C and D. So C, and remember, is your horizontal translation. Okay, so C is your horizontal translation. It moves it left and right. And D is your vertical translation. It moves it up and down. Okay, and that affected your vertical asymptotes a lot, but it's also going to affect your domain and your range. Okay, if we look at Desmos again, here's one where we have a D of 5, so it got moved up 5. We can see that that's going to not really do anything to the domain. The domain is the x's, right? And the domain is really dependent on that vertical asymptote, which is still at x equals 0. So our domain here is still the same as it was before when it was just 1 over x. It's going to be all real numbers except for 0. But your range used to be all real numbers except for 0, but it's definitely not that anymore. Let me make this a little bigger because we actually can see that it touches 0 right here. Okay, our domain is, our range is affected by the horizontal asymptote, and the horizontal asymptote got moved up 5. So if you know where the asymptotes are, you know where the domain and you know what the domain and the range is. Okay, so in general, our domain is going to be basically only affected by C. Actually, hold on. Okay, let me actually put a C in here. So a C would be in the denominator with this. Okay, so if I have 1 over x minus 2, you can see that now my domain is going to be dependent on everything except for 2. It's going to be dependent on that vertical asymptote. So the key idea here is the domain is affected by C. The range is affected by D. Okay, so that's what we're going to write down. So our domain is basically, you could say all real numbers except, but I'm just going to write it in shorthand. X cannot equal whatever C is. The range is going to be affected by that horizontal asymptote. It's going to be Y cannot equal whatever D is. Okay. And the end behavior is dependent on the horizontal asymptote. Okay, so in this case, my horizontal asymptote was at 5, which is the D. So we could see that it's going to approach that number. Okay, so our end behavior, as x goes to infinity, y approaches whatever D is. And it's the same when x approaches negative infinity, y is approaching whatever D is. Okay, and I'm just going to make a note here that the C becomes the new vertical asymptote. And the D becomes the new horizontal asymptote. So let's talk more about asymptotes. What determines a vertical asymptote? Pretty much a vertical asymptote is determined by what value of x will make the denominator 0. Okay. What x value makes the denominator 0? Because we cannot divide by 0. Okay. So we already kind of talked about these. If we add 5 here, we're going to go up 5. If we add 5 in here, we're going to, that's actually subtracting a negative 5 because it's x minus c here. So this is going to go left 5. Sorry, my left is funky. Okay. You can watch the first video and it'll show you these examples exactly. Okay. All right. So let's write a rational function, g of x, that matches some of these characteristics. And actually, there's one part, number 2, I forgot. When does a rational function have more than one vertical asymptote? So we said whatever x value makes the denominator 0 gives you a vertical asymptote. Could there be more than one? Yes. Okay. If more than one number makes the denominator 0, you have more than one vertical asymptote. Okay, so what does that look like? Well, let's do A and B. So A, we just have one vertical asymptote at x equals 2. So that means we're going to have to subtract 2 from the denominator, because when you plug in 2, 2 minus 2 would give you 0, and that would give you a vertical asymptote. The horizontal asymptote comes from the D, which is the 1. That's the equation. So let's just sketch it. So we have a horizontal asymptote at 1. So we'll just say this is 1. And a vertical asymptote at 2. 1, 2. And we haven't changed anything else about it, so it's going to have the exact same shape. These branches like this that we saw. Okay, what if it has 2 vertical asymptotes? Okay, if it has 2 vertical asymptotes, you're going to multiply 2 linear factors. So if it has x equals 1, think about the zeros you learned from the polynomials. Think 1 is basically going to make one of those linear factors 0. So it's going to be x minus 1. And the other one, how do we get negative 5? You get x plus 5, right? If we plugged in negative 5 there, even if we had to plug negative 5 in for both of the x's, which we would have to do, if the one on the right turns into 0, who cares what this is? It's going to turn into 0 because we're multiplying by 0. Okay, and our numerator we're just going to keep as a 1. And horizontal asymptote, they want it at y equals negative 3. So we could just put a minus 3 at the end. Now, you can vary this. You could make this one 2x minus 2, because that would still give you a 0 of positive 1. It doesn't really matter. You can change the 1 at the top to a 4. It's still going to give you all these things. It's just going to change the shape a little bit. Okay, so then we can sketch it out. We can sketch a vertical asymptote at x equals 1, and then negative 5. 1, 2, 3, 4, 5. Make our dotted vertical asymptotes. And our horizontal asymptote at y is equal to negative 3. So what does that look like? Well, you're not going to touch all these things generally, and the horizontal asymptote is going to depict the end behavior. You're actually going to have like 3 sections in this. But if you're not sure, let's just graph it. Let's go to Desmos and see what Desmos is. Okay, so I'm going to just adjust this one, put parentheses around this, make this an x minus 1 times an x plus 5. Oh, you're starting to see what it looks like. And then we had a minus 3 at the end. Look at this. Okay, so you basically have 2 branches swooping that way and then one kind of like that. Okay, so we're going to have, I'll use a different color here. Something like this, something like this, something like this. It's just a sketch. We are not making anything perfect. We're not plotting points. It's just generalized, okay? Let's see. Let's see if you guys can do C and D. Go ahead and pause the video and give C and D a try. And then when you're ready, I'll show you what it looks like. Or honestly, they're examples. They could be slightly different though. Pause. Okay, so for my one on the left, it said f of x minus 2 minus 4, so this is c. So then our horizontal shift c is 2, and our d is negative 4. So it's going to go to the right 2, down 4. So you can see I've got a vertical asymptote at 2 and a horizontal asymptote at negative 4. And then my equation is 1 over x minus 2 and then a big minus 4 over to the on the end. And then this one can vary because it didn't tell you how many spaces up and to the left. They just said up and to the left. So just to make sure that your number at the end here is positive something, I did positive 4. And then this is also going to be positive because this c is going to go opposite, right? So it's actually x minus negative 3. Negative 3 is going to go to the left, but it turns into a plus. Okay, and then my branches. Okay, we're going to look at a couple more from activity 2 and activity 3, but basically we're going to look at the ones that have more than one vertical asymptote now. Okay, so in activity 2, we have this function, 1 over x squared minus 4. There are two undefined points here, one at negative 2 and one at 2. And so we get the two vertical asymptotes. You can see them right here. So if you look in the function, look at what you have in the denominator, x squared minus 4. What this essentially is a polynomial. It's a difference of squares that you can factor. And we know that that's going to be x plus 2 times x minus 2. So there's two numbers that could give you 0 in that denominator. If you plug in negative 2, it's going to make the one on the left a 0, and the whole denominator will turn 0. If you plug in positive 2, the one over here on the right will become 0, and the whole thing will be 0. Okay, so let's jump to number 4. And we're going to look at a couple of these, not all of them, but we're going to look at a couple of them, and we are going to sketch them, find the domain, the range, the asymptotes, and the y-intercept. But I would not do the sketch first, but I mean, you can. It says without technology, so we are not using Desmos here, okay? We're using what we understand about vertical asymptotes and domain and range. So here, if you look in the denominator, we have x minus 2 and x plus 4, which means the two numbers that make that denominator 0 are positive 2 and negative 4. So how do we write that in the domain? You could write x cannot equal 2, comma, negative 4. With interval notation, you can say it's from negative infinity to negative 4 open union, and then from negative 4 to 2 open, right? No brackets here because we do not want to include these numbers, union, and then from 2 to infinity. But that's basically saying everything except for negative 4 and 2. And those are basically your asymptotes, your vertical asymptotes. So our vertical asymptotes are x equals 2 and x equals negative 4. Basically exactly the opposite of what I said for the domain. But the domain is saying we can't have these things. The vertical asymptote is showing where they are. So we can sketch that. We can go, okay, positive 2 and negative 4. Okay, and we are going to draw some vertical lines. Now there's no d value at the end here. So the horizontal asymptote is going to remain at the x-axis, or y equals 0. It didn't change. Okay, so we can draw that one in. Okay, our range is going to be everything but 0. Okay, y cannot equal 0. Our y-intercept. Okay, how do we figure out a y-intercept? Basically, you're going to let x equals 0 and solve for y. So I'm going to plug in 0 into this function. 1 over 0 minus 2 times 0 plus 4. See what I get. Let's see. 0 minus 2 is negative 2. 0 plus 4 is 4. You get negative 1/8. So the y-intercept is the point 0, negative 1/8. And that's going to be like right here. We can sketch that. And just like the one that we did before, basically you're going to have a section go like this. So it's going to be kind of almost not quadratic, but kind of like a shape like a quadratic going opening down. And then you've got the 2 branches, and they're going to be on the top. So what I suggest you do, I know it says without technology. I am good with you guys just trying your best based off of the information that you know, and then going and checking what does Desmos say it looks like. How close were you? Because I don't want you to just assume it's right and go from there. So let's see. So x minus 2 and x plus 4. Let's look, and so you see we have the horizontal asymptote at the x-axis, and that is negative 1/8. That's our y-intercept right there. Okay, cool. Now that one was already factored. Let's do one where it's not already factored for us. So this denominator right here, x squared minus 2x minus 8, that is not in factored form. So the key thing here is you have to factor it first. So we're going to factor x squared minus 2x minus 8. That is a diamond problem. So 2 numbers that multiply to make negative 8 and add to make negative 2 would be negative 4 and positive 2. So this is going to factor into x minus 4 times x plus 2. Okay, so our domain is x cannot equal 4 or negative 2. So positive 4 and negative 2 because you're using the zeros, right? What would make them 0? So our asymptotes are at 4 and negative 2. Okay, our range is still going to, and our horizontal asymptote is still, this is the vertical asymptotes. I'll say VA. Horizontal asymptote is going to be y is equal to 0. It's not changing. So our range is still y cannot equal 0. Okay, and then our y-intercept, we're going to plug in 0 to this function. 2 over 0 minus 4 times 0 plus 2, which is 0 minus 4 is negative 4. 0 plus 2 is 2. It's negative 1/4 when we reduce it. Okay, so we sketch it. We're going to have our asymptotes at negative 2 and positive 4 for vertical. Horizontal asymptote is at the x-axis, which is y is equal to 0. Let's put our y-intercept point, which is still kind of barely there, and sketch it. Okay, so there's another one of those that I want you to do on your own, and I want you to go ahead and look through activity 3 on your own and check your answer key as you go. There is a section where they want you to find the vertical asymptotes. There's some with 3 vertical asymptotes. Now, In some cases, if you try to figure out what makes it 0, there might not be any real number that makes it 0. For example, this one we have 2 over x squared plus 2. You can't factor x squared plus 2. If you try to figure out what makes it 0, you can set it equal to 0 and solve this. You could use the quadratic formula, for example. Or you can just solve it by subtracting 2 from both sides and trying to square root, plus or minus square root. And then at this point, you should recognize that's imaginary. You square root a negative number, it's imaginary. So when we're looking for vertical asymptotes, we're only looking for real numbers because those are the things that are on the x-axis. If there's no real numbers, this has no vertical asymptotes then. It is possible they don't have to have them. If there's no real number that makes the denominator 0, then you don't have to worry about it. Okay, good luck with that assignment. I hope this was helpful.